Hello, Algebra 1 students, and welcome to Lesson 3 of Unit 1. Within this lesson, we are going to talk about multiplying and dividing real numbers. So that is your objective for the day, is that I can multiply and divide real numbers. So remember, that's going to be whether they're decimals, fractions, negative numbers, or positive numbers. So our agenda for the day is we've got about 4 examples on how to multiply and divide your integers, as well as we will review those rules on how to multiply and divide those numbers. So I know last time I had forgotten about your code word, so make sure I'll try my best to continue to remember. Just follow the directions whenever I put something in the directions for the actual assignment. And so for this one, just make sure you're listening for that code word. Alrighty. So talking about your product or your quotient, and they kind of do it down here, but here's kind of your basic key. And I kind of like this part here. Let me get my pen going. It's a pretty basic key, but it makes it simpler in a sense. So if the numbers are both positive, your answer or your product or quotient is going to be positive. If one is negative, your answer or your product or quotient is going to be negative. And if both the numbers are negative, your answer is going to be positive. So that's basically the biggest understanding. And I know for the most part, this should be review. But if you want to read the rest of this, you can always pause it and continue reading this. But the biggest takeaway is this little chart, which should also be a really good helpful tool if you have a hard time remembering that, and maybe just putting it on a sticky note and sticking it on your computer. So let's go ahead and do some examples of it. So example 1 is multiply and divide signed numbers. So find the value of each. So again, we're going to think about looking at the signs. So in this case, I've got a negative 12 times 5. They are opposite signs, so when they are opposite signs, or you have one negative, one positive, you're going to have an answer being negative. So I'm going to take 12 times 5. 12 times 5 is 60 because 1 times 5 is 5. 10 times 5 is 50. 2 times 5 is 10, so you get 60 when you add the two together. Keep that negative sign. All right, so then the next one, again, remember this is another way you can show your multiplication. I'm going to write it out a little easier so it's a little easier to see. So it's like I have 8 times negative 5/8. Now, this is a lot like saying 8 out of 1, because remember every number can be divided by 1, times then a negative 5/8. And the negative, usually when we do mathematics and we talk about things like this, we try and keep the negative at the top. So if you think about your cross multiplication, or you could use, you can multiply across when you multiply your fractions, but really since I have an 8 on the top and an 8 on the bottom, they cancel each other out. So I'm left with 5 out of 1 or negative 5. Remember that one was positive, one was negative, so I keep that negative. And that is my solution, or my product. Alrighty, so it says 2 numbers are reciprocals if the product is 1. A number and its reciprocal are called multiplicative inverses. I usually just say your inverse. And so that's how we were kind of talking about, okay, well, it's 8. And the bottom had an 8 in it. So in that fraction, that 5/8. So if you have something like 4, in this case 4 and 1/4, well, if you multiply those together, they give you 1 because 4 out of 1 is, or 4 is the same as 4 out of 1, 1/4. You multiply them across, well, 4 times 1 is 4, 1 times 4 is 4. Well, 4 times 4 then equals 1. And so that's what they're talking about, this multiplicative inverse. Okay, so you can do that for any sort of number. They use an example of negative 3 because if you had then the fraction of negative 1/3 and you multiply that out, so again, it'd be kind of the same as, 3 out of 1. Well, negative 1 times a negative 3 is a positive 3, and a positive 3 times a positive 1 is 3, still means 1. All right. The biggest thing, and then what they talk about here too, is that a can't be 0, because if you ever have plugged into something divided by 0, maybe we make this 5 divided by 0, you can't do that in a calculator. It actually gives you an undefined operation. They call it undefined or something. Sometimes it'll come up as error. So let's go ahead and talk about dividing with fractions. So let's go ahead and take a look. In this case, I'm going to rewrite this. -4/5 divided by -8/15. Remember, when we divide fractions, we don't actually divide them. We change the operation. And so what we do is we keep the first fraction, so -4/5. We change the sign to multiplication, and we flip this fraction. So I'm going to put the 15 on the top and the -8 on the bottom. So it's keep, change, flip, or sometimes it's, you can say yeah, I think there was another way I was trying to think of that I've remembered. You just change the multiplication and you flip it. I thought there was a better saying for it, but I guess I can't remember. So then I'm just going to go across the top and multiply. So -4 times 15, well, that will be -40, -60. And then on the bottom, 5 times -8, well, that's -40. I was to simplify this, you can get rid of the zeros and the negatives because they'd cancel each other out. You'd be left with 6/4. Or you can reduce this down to 3/2. Or you could say 1 1/2. I'm not going to be picky on the form of your fraction as long as it's, it can be either a mixed number or an improper fraction, unless I'm very specific on it. Alrighty, and then the next one, we've got -4 divided by 9 1/4. So in this one, we're going to do the same thing as a keep, change, flip. But before we go too far, we're going to make this 9 1/4 into an improper fraction. So if I want this is an improper fraction, I'm going to take the 9 times the 4. 9 times 4 is 36. I add it to the 1 up top, so now I'm going to have 37 on top and 4 on the bottom. Okay, so that's how I got the top part again. I just take the 9 times 4, which is 36, add it to the numerator, keep that same denominator. So now I'm -4, or divided by 37/4. Remember, we are going to keep this, so -4, change the sign, and we're going to flip our fraction. So 4/37. Now, -4 is not already a fraction, or can be written as a fraction. It technically could be a fraction, actually. It's just not written as that. So -4 out of 1, because remember, any whole number can then be out of a 1, or any integer, really. And we're going to multiply across. Well, -4 times a +4 is -16, and 1 times 37 is 37. I'm pretty sure 37 is an prime number, and so I'm pretty sure that this is your final solution, but give me just a minute to double check. Yeah. I just want to make sure I wasn't feeling like you could divide it by 3 or something. And that's it. Can't simplify it any further, so that is going to be our solution. Again, feel free to pause the video at any point if you feel like you need to. Make sure you're watching out for that code word. Alrighty, so here's a couple more rule things to look at. It says the number 0 has a special property of multiplication and division. So in the case that you are any number, remember your rule of the multiplying by 0, any number multiplied by 0 is going to be 0. Dividing by 0, you can always have a 0 on your numerator or as the first part in your division problem. So in this case, here's the numerator, first number in your division. But as I kind of started to talk about, you cannot divide anything by 0. It's basically you took 12 apples and you're trying to split it between nobody, not even yourself. Like no one gets them. They're going to like disappear into thin air. So it's not actually possible in the real world. And so we call that undefined. So that'll be important because we will be talking about other things too in the world of algebra that will end up having things that are undefined too. Hey, your code word is blue. That's what I'm deciding it is. All right, so let's talk about multiplying and dividing by 0. So let's go ahead and take a look at some of these. So if I have 0 minus 16.568, well, again, if we talk about thinking about our integer rules, and if you thought about a number line, well, we always start at 0, okay? And so then we'd go to whatever that first number is, or first integer. And in this case, it's 0, so we'd start at 0. We're going to subtract. Subtracting means I'm going to go to the left, and I'm going to the left this amount. So really, then my answer is just going to be the negative version of this number, which is negative 16.568. That's my answer. Pretty straightforward. B then, I know it's written a little funny, but it should be 63 7/8 divided by 0. Remember, you can have 0 first, but you can't divide by 0, so I would say this is undefined, or you can put UND, not like the college, but you can abbreviate it so that you don't have to write it all out, but I'm not a good speller. Define. Is it just D? ED. ED. All right. And your last one, 1 times 0. Pretty sure you're going to know this. It's just anything multiplied by 0 is 0. And that's your solution. Basically, I made it look like a donut now. Alrighty, let's get to our last problem here in our real world example. This one says it's a recreational application. Looks like we're going to be talking about a hot air balloon. So a hot air balloon is taken for a 2.5-hour trip. The wind speed and the speed of the balloon is 4.75 miles per hour. The balloon travels in a straight line parallel to the ground. How many miles away from the liftoff site will the balloon land? Oh, so this one, we got to think about what we need to do with our numbers. So here's our actual question. How many miles away will the liftoff site for the balloon? So I'm underlining my problem. Let's think about our operation. Is taking to the wind speed. I think your operation is going to be, this is probably where your clue is. Miles per hour, and we were given hours. So I'm betting that what we're going to need to do is either going to be multiplication or division. So then I'm going to also think about my 2.5 hours for the trip, and we have 4.75 miles per hour. Or sorry, 2.5 hours. I think I said miles. Alrighty, so one way we can do this is thinking about the proportions. So in this case, they say 4.75 miles per hour. So I could say 4.75 miles for every 1 hour. So I'm setting up a ratio right now, so that can help in one way. If I set up a proportion and I solve this out, then I want to keep the same operation or the same measurement on each part. Alrighty, so then if I'm going to keep with this same proportion, I'd have the miles at the top. I don't know how many miles that is though. And then on the bottom, you'd have 2.5 hours. So if you use your proportion rules to find your x, you do what is called the cross multiplication or cross products or butterfly method, whatever you like to call it. And so what ends up happening is you take the opposite parts and you multiply them. So in this case, then I'd have x equals, because 1 times x is x, 4.75 times 2.5. And so really my operation in this one is multiplication. Apply the two together, you get an answer of 11.875 miles. All right, and that is your solution. I will catch you guys tomorrow or the next day when we are working on these problems together. See you then. Let me know if you have questions.